Hello, algebra. Let me get that bigger. And let me zoom in a little bit. So we are starting lesson 6.3, which is all about exponential functions. You guys have heard me say before, we are living an exponential function right now with this pandemic, and we're going to learn what that means. What does that mean? So our essential question, what are the characteristics of exponential functions and their graphs? What is an exponential function? Well, it's a nonlinear function, so it doesn't make a straight line, right? Nonlinear, where the independent variable x changes by a constant amount. The dependent variable y is multiplied by a factor, which means consecutive y values form a ratio, right? They form a ratio. We're going to look at some tables in a minute. We're going to determine if they're linear or if they're exponential. And we know that exponents, the more exponents we have, the more we are multiplying that number, right? So I'm going to give you a hint there. It should be multiplying somewhere in here. Exponential forms have, or exponential graphs have the form y equals a times b to the x. All right, so the x is an exponent. And b is going to be greater than 0 and not equal to 1. The y values change by a factor of b as x increases by 1. So every time we're adding 1 for our x, okay, that's not changing. That's very normal, so to speak. That's what we saw when we had linear equations. But now you'll notice with this one right here, there's a ratio here. If I were to look at it, I could say, well, 2 to 10, I'd have to add 8. 10 to 50, I'd add 40. 50 to 250, I'd add 200. 250 to 1250, I would add 1,000. So we can already see I'm not adding the same amount each time. I'm adding more. And how much more? How do we figure that out? Well, that's where we look at it and we say, well, how could I multiply to get from 2 to 10? In this case, let me get rid of that, sorry. In this case, I would have to multiply by 5, right? To get from 10 to 50 times 5. From 50 to 250 times 5. So you can see what the pattern is. So this right here is the b. That's the constant ratio. We're multiplying by the same amount. So that's how you know if it's an exponential, is if you have a constant ratio that is being multiplied to get from one to the next, to the next, to the next. For the a portion of this, a is actually your starting value. So in this case, when we're looking at this table, we start with 0 always, right? So that means this 2 here is our a. So we need to look for where x is 0 and our a is 2. So we're going to write this function. We know that we have a times b to the x. Well, our a we just said is 2. I'm going to give myself some parentheses here and put my x outside them. And then b we know is 5. That's the exponential function right there. That's it. Y equals 2, parentheses, 5 to the x. So how do we know if it's different from a linear, right? If we know it's an exponential or a linear. So I want to remind you that we know what a linear is. Y equals mx plus b, right? We've seen it many times before. So we're going to look at some of our tables here, and we're going to determine if it is a linear or an exponential. And then we want to write the function. All right. So I always like to start with just seeing if it's a linear, because that's way easier for my brain. So I just want to look at this first one right here. I use sticky notes because I like to do it one way, and then I like to see, what happens if I look at it the other way, so to speak. Let me show you what I mean. To get from 2 to 4, I would add 2. To get from 4 to 6, I would add 2. To get from 6 to 8, I would add 2. So I can see right here, because I am adding each time, this is going to be a linear. Right? It's a linear because I'm adding 2. So then what's that equation? Well, I would need to figure out what my slope is, and I need to figure out what intercept is. Now, the slope is whatever your rate is. We just found that. That's 2, right? Plus 2. And then my y-intercept is wherever I'm starting. Remember, that's going to be a point, 0, comma b. So in this case, when I look here, I see that my b value is a 2 because I'm starting at the point 0, 2. So that means this equation is y equals 2x plus 2. That's my equation. There's my slope. There's my y-intercept. So let's look at our next table here. I'll get another sticky note. I'm going to start by seeing how I can add to get from each value in my y column. So to get from 4 to 8, I would add 4. To get from 8 to 16, I would add 4. To get from 16 to 32, to get from 8 to 16, I would add 8. To get from 16 to 32, I would add 16. So I can see that linear does not work, right? Linear does not work. So I'm going to get a new sticky note. I'm going to cover that up. You could just remove it if you wanted to. Either way would work fine. And now I'm going to think about, okay, well, if adding didn't work, let's try multiplying. 4 to 8, I would have to times by 2. 8 to 16, well, 2 times 8 is 16, so I'd times by 2 again. 16 to 32, well, 2 times 16 is 32, so I times by 2 again. So we can see that we have a constant ratio here when we are multiplying. So that means that this is an exponential, and it's because I am timesing by 2 each time. So what's my A value and what's my B value? Well, the B value we just found. It's this times 2 each time. That's my B value. The A value is where do we start? Remember, that's that 0, A. And I know that with our linears, we use the B as well. I don't know why mathematicians had to use a variable multiple times for this, but just remember, a variable can represent anything, okay? So with an exponential, it represents the rate, and with the linear, it represents your starting value. I guess they were just too lazy to come up with another letter. I don't know. Not lazy, efficient? So with our A value here, we're looking in our table, and we know that A is going to be wherever X is. So this right here is our starting value, A. And that's because X is 0. 4. So when I go to write this function, we know it's going to be y equals, there we go, A times B to the X. So this would be y equals our A we said was 4. I used parentheses, and then our B was 2, and then we just put our X there. So this is our A. This is our B. All right. I want to do this one with you guys as well, and then I will let you practice on some of these. All right. So for this one, again, I always start off with doing our addition. So to get from 8 to 4, we would minus 4. To get from 4 to 2, I would minus 2. To get from 2 to 1, I would minus 1. I'm not doing the same thing each time, so I know that this is not a linear. So let's try multiplying. And this is where you might look at me and go, well, you can't be multiplying, you're dividing. You're right, but you can also multiply. So let me show you both ways. So to get from 8 to 4, I would say I'm dividing by 2. To get from 4 to 2, I would divide by 2. And to get from 2 to 1, I would divide by 2. So we can see that this is going to be exponential. Because we're dividing by 2 each time. Well, then you look, how do I write that as B, as my rate? This is why I encourage you to do it as multiplying, okay? Because multiplying works out a little prettier, so to speak. The dividing by 2 is completely accurate, but then you run into an issue when you look at your B. So for exponential, I'm going to say I'm going to multiply. Well, what would I multiply by to get from 8 to 4? Think about the fractions that you know. What could you multiply by 8 to get to 4? Hopefully you guys look at me and go, well, 4 is half of 8, so I'd multiply by a half. And 2 is half of 4, so I'd multiply by a half. And 1 is half of 2, so we'd multiply by a half. So what's really nice about this is that we are multiplying by 1/2. And you have to multiply, all right? It doesn't work for dividing by 2. It has to be multiplying. Has to be. So with this one, we know our B value is going to be times 1/2. Now, if you like the dividing by 2, just remember, anytime you see divide, it means a fraction. So if you divide by 2, it means you're really multiplying by a half, right? Because this bar right here is the symbol for divide. So dividing by 2, timesing by 1/2, they're the same thing. I just think my brain likes it better when I times by a half. So now we can look at this and say, okay, well then what's our a value? What is our a value? What is our starting value? Oh, look, it's right there. When x is 0, a is 8. So I can write this as y equals 8 parentheses 1/2 to the x. So we've got 3 more on here. I already showed you for these ones that I'm adding by 1 each time. I encourage you to figure out what the function is. Linear, exponential, write the function. So pause the video, take a second. All right, for our next part here, we are evaluating, as my pencils roll everywhere. We are evaluating exponential functions. So this is why we learned all of those exponent rules. And you guys were like, exponent rules. Yep, this is why. This is why. It's super, super important. You don't even need a calculator to do any of these. And I'm going to show you that. So for our first one here, we want to evaluate the exponential function at x equals 0, x equals -1, and x equals 2. I'm going to start with -1. All right. So I'm going to do all 3 of these. So I'm going to write down my equation. Y equals -2, 5. And then in this case, x is -1. So I am switching out this x, and I'm plugging in -1. Well, wait a second. I know what a negative exponent means. It means that I need to move it to my denominator to make it happy. Or from the denominator to the numerator, right? I just have to switch him, either from the attic to the basement or basement to the attic. Now, 5 is actually living in the attic right now, right? There's a 1 in the denominator, so I'm going to flip him. So this becomes y equals -2 times 1/5. And that 1 becomes a positive. Well, wait a second. I've got 2 times 1/5. I know how to do that. That would become y equals -2/5. And that's the answer. That's it right there. So then what about the 0? This one's probably going to be the one you guys like the best. So y equals -2, 5 to the 0. So I'm literally just plugging in whatever this is for my x. Well, wait a second. Anything to the 0 is 1. So I really have -2 times 1. Hey, wait a second. That's really y equals -2. All right, now let's try our 2 here. So y equals -2 times 5 squared. Well, I know what 5 squared is because that's a 5. That's 25. And then 2 times 25, well, it's a -2 really, so it would be -50. So there we go. You know for each of these what the value is. This would be the point -1, -2/5. This would be the point 0, -2. And then this would be the point 2, -50. So as time goes on, it's more and more negative. Kind of like a credit card. And by the way, this is really, I think, the most applicable, like you're going to use this every day in life. Anytime you have a loan, it's an exponential function, all right? Anytime. So yes, we are living in a pandemic, which is an exponential, and we'll look at that more with graphs in a minute. But also, you use it with money. Any type of loan, any type of credit card, anything like that, it uses exponents. All right, so for this one, I also wanted to include an x equals 1/2, okay? Because we just got done learning about our fractional exponents, what they mean, how we can use them. And again, this is why I did that, all right? We did that before this because you're going to see things on here that will have fractional exponents, and I want you to understand what that means. This just means that we could take a radical, right? So it's a perfectly valid, like you could have half of a day of interest on your credit card. Is that annoying? Yes. But it's true, or half of a year on your car loan. So let's take a look at evaluating these. We're going to start with the x equals 1/2. Then we'll do x equals -1. Then we'll do x equals 0. And we'll finish off with x equals 2. So with this 1/2, we would have y equals 2, 9 to the 1/2. Right? Because I'm just substituting that in. Now that 1/2 means I'm really taking the square root of 9, right? 2 times the square root of 9. And there's a little 2 there if you really want to have it. Well, I know what the square root of 9 is. It's 3. So this is really 2 times 3. So we actually have y equals 2 times 3 is 6 for our first one. 6. So I just want to remind you, you know how to do that, right? You know how to do that. For our next one here, we've got y equals 2 times 9 to -1. Again, we know that means our 9 moves to the denominator. So we have y equals, I'm going to set up a fraction. So my 9 moves down here, the 1 turns positive. And then that 2 is going to stay in the numerator. So 2/9. Let's try our 0. Y equals 2 times 9 to the 0. Anything to the 0 is always 1, so this is y equals 2 times 1. So that's really just y equals 2. And then x equals 2 here, so y equals 2 times 9 to the 2 in this case. Well, 9 squared is 81. And then 2 times 81. Okay, you might need a calculator for that, but I don't think so. Because you can do 2 times 8, which is 16. And you know that 2 times 1 is 2. So this would be 162. Now with this guy, you are welcome to leave it as a decimal. I know how much you like decimals, so that is fine. This one down here, because it's a 3, do not round it. Okay? Leave it as a fraction. Leave it as a fraction. So I want you to try the next 4 on this page out. Email me if you have questions, and the skills practice is posted to Big Ideas. Oh, and the answers are on the answer key.